Hello all. So we are going to continue the discussion with respect to linear algebra. Now we are going to start a very new topic which is called as Introduction to Projections. Now in order to understand projections, let's first of all take a very good example. So here let's consider that I have this coordinate system, and in this coordinate system let's consider that there is some kind of vector over here. Okay, so let's say this is my vector. Okay, and if I probably go ahead and connect this vector looks something like this, and this is the direction of this vector. Okay, now with respect to this particular vector, now you should understand that from this vector I can definitely create a line. Okay, and this line, if I try to multiply with any coordinate, let's consider that this vector is specified as vector v. Okay, so if I probably multiply with any scalar value, let's say scalar c multiplied by v, and this scalar belongs to a real value, right? So it belongs to a real value over here, or a real number. It is a real number itself. So here you will be able to see with if I'm multiplying with this scalar, I can convert this vector into a straight line. It can extend till here, or see, it can probably extend till here, or it can also come down, right, based on the c value. So this is my entire line, right? So I'm actually trying to create from a vector, right? I'm trying to create a specific line over here, and you can just see, right? If I probably extend this vector over here, or if I extend it downwards, right? It's just like multiplying with a specific scalar value, right? Now let's consider one more thing. Let's consider another vector. So let's say here is one more vector, and this vector is nothing but it is denoted by x. Okay, so let's see this. Let's say that this is my vector. This vector is specifically denoted by x in this sign, right? So I'm just going to use a vector x. Now let's consider one more very simplistic, let's say that here I'm just going to, if we are considering this particular vector, and if I'm considering this specific line, let's say a kind of straight line, a kind of sunlight or sun rays, or let's say here what I have done is that I have just there's a source of light. Okay, so let's consider there is some source of light over here, and it is projecting on this specific point, right? Now when it is projecting on this specific point, now you know that this x is basically going to fall. It is going to fall over here, right? It is going to fall over here. And once we project any source of light, let's say if I'm trying to put a source of light over here, what it is going to happen, the rays of the light will fall on this, and the shadow of x bar will fall over here, right? Now this is nothing but, this is basically called as projection of this x vector on this specific line. So if I really want to see that what will probably be this length, what will be this specific length, we basically specify this length as projection of vector x to the line L, right? And if I really want to go ahead and explain this, what exactly this is, projection of vector x to L, it is nothing but it is basically projecting the vector x on the line L, right? On the line L. This is what we are specifically doing. Okay. There's some more. Now, see, at the end of the day, what we really need to do is that we need to find out what will be this projection of the new point over here for this particular vector, right? If I'm projecting this particular point over here, right, what should be the specific point? And that is what I really want to know, right? So for this, what I will do is that I will just go ahead and I'll use some kind of text to explain you this. Let's say if this is my projection of vector x to L, I will say that, hey, some vector in L. So if I really want to calculate this, what this is actually a some vector in L. It can be here, it can be here, it can be based on this specific vector. See, I may also have one more vector which looks like this. Let's say this is my new vector, right? Now, if I probably project this vector on this particular line, I should be getting somewhere here. So this should be my projection, and this should be my projection for this particular vector. This vector, I can specify it as y vector, right? So I would definitely like to know what is the projection of y on this specific line vector, right? So if whenever I talk about projection of any vector on a line, I'm just talking about some vector in line where okay, where let's see one more scenario, and this is important. What does this line basically specify? See, observe this specific line. Okay, if I want to calculate the length of this line, what exactly this is nothing but x vector minus, okay, x vector minus whatever vector I am having it over here, right? Whatever vector I am having it over here, and this line is nothing but this is basically my projection of x vector on L, right? This is what we are able to find it, right? So over here, you'll be able to see that I will be getting this specific line, and this line is also perpendicular to this particular line. See over here, when we say perpendicular, here 90 degrees basically created, right? Or here 90 degrees basically created. So this is also one condition. Whenever I say projection of L, projection of a vector x2 line L, I can say it is talking about some vector in line wherein this x bar minus projection of L, or projection of L to x bar is basically projected on L, is perpendicular to L. Is perpendicular to L, right? This is what we specifically mention it, right? Perpendicular to L. Now guys, I want to cover a very important property regarding this. Let's say what happens when we have a vector perpendicular to a specific line. What exactly this basically means, okay? So let's consider this, and here I will probably show you about this particular property. Let's say that I have this coordinate system. Let's say I have a vector which specifies a direction. Let's say the vector is a12. Okay, I'll just go ahead and use this particular vector. Let's consider two vectors, a12, 1, 2, and b is nothing but it is basically mentioned as -2, 1. Okay. Now, first of all, what we will do is that we will go ahead and let's consider this is my a coordinate. Okay, this is my b coordinate. Okay, and here I have my b coordinate. Okay. What I'm going to do is that I'm just going to go ahead and plot this. Okay, so what is a12? 1, 2 basically means this is 1 and this is 2, right? So here is my point, right? Similarly, if I go ahead and plot -2, 1, -2, 1 basically means, so this is my 1, 2, 3, 4. So -2 is nothing but this one, right? -2, 1, right? So this is the point. So this is my a, which is specified by 1, 2, and this is my b, which is specified by -2, 1. Okay. Now, whenever I talk about this particular a vector, this is this line, right? It is nothing but here. Let me just go ahead and create this specific line. Okay. And when I probably talk about this vector, this is nothing but this is this line. Do you see one property for this particular vectors? Both these vectors are perpendicular to each other. Okay. And here also you can see it is 90 degree, right? Exactly 90 degree. Now, if I want to convert this vector into line, what I can do is that I can multiply any scalar value c with a, right? So when I multiply c with a, this is going to probably go over here. It can be extended over here. It can be extended over here, right? So when we say that, hey, both this line and this vectors are perpendicular to each other. So if we do the dot product, what is going to happen? See, if I go ahead and write a dot b, so here you know that a is nothing but it is 1, 2, and when I do a dot of with -2, 1. Now, if you remember what is a dot b, if I have a as a1, a2 and b as b1, b2, what exactly happens, right? When we do a dot product, it is nothing but a1, b1 plus a2, b2, right? This is what we are going to specifically get, right? And I hope I have covered all this particular topic. So when I do a dot operation over here, so here I'm actually going to get 1 multiplied by -2 plus 1 multiplied by -2 and 2 multiplied by 1, right? So overall, I'm going to get 0. So this is really important. Whenever a vector is exactly perpendicular to the other line or other vector, this dot product is obviously a 0 value. So dot product is always 0. Okay, of that specific vectors, and that is what I have proved it over here, right? So let's go back to this and let's discuss more about this over here, right? So here, if I just copy this and paste it over here, now let's go back over here and let's discuss about this. Now we are talking about the projection, and this projection is nothing but some vector in line L where this projection is perpendicular to the L, and this projection basically means this specific line, right? Now we will proceed further and we'll probably discuss about this, and we'll write this in the form of equation. Now you know that when I say, hey, this projection is perpendicular to L, that basically means what? If this is perpendicular to L, that basically means this product, this vector, if I probably consider this subtraction, multiplied by whatever vector this is specified as, V vector, the dot product will be 0, right? So I will just go ahead and write it over here. X bar, okay, X bar minus, what is projection of L to X bar, right? What is the projection of L to X bar? You know that whenever I try to project X bar to L, I'm going to get this, right? It should be a scalar value of any vectors, because it can be extended here, it can be extended here, right? So my projection of L on X will either be getting extended here or it will be getting extended here. So I can definitely use this as my projection, right? C multiplied by vector. So here projection of L, projection of any vector X to L will be denoted by C multiplied by vector V. Okay. So here what we will be doing is that we will go ahead and write C multiplied by vector V, right? And when we do this dot product, right, to dot product to any vector, this is basically going to give me as 0, right? This is actually going to give me as 0. Why? Because both of them are perpendicular to each other, right? And this is really important for you all to understand. Okay. Now what I will do is that I will take this one step ahead. I will write X bar dot V bar. So X vector multiplied by V vector minus C vector multiplied by V vector, right? And when we specifically use this, since this side it is 0, okay, this side it is 0, I will take this entire value to this side. X vector V vector is equal to C vector dot product of V vector, okay? And finally, if I really want to calculate C, it is nothing but X dot V divided by V dot V, okay? Now we will go ahead with one more step, okay? Now let's go ahead and talk about this projection, because this is finally what we want to calculate it, right? So if I go ahead and write projection of L with respect to vector X, which is given by C multiplied by vector V, right? Or C multiplied by vector V, this C will get replaced over here, right? And C is nothing but it is X bar, X vector, V vector divided by V vector, V vector, right? So here I have this entire value of C, right? Or instead of just using this brackets, I will use another brackets. Let's see over here, okay? So I will go ahead and write like this, square brackets. I will say X vector dot product with V vector dot product with itself multiplied by or dot product with V vector, right? And this is what you are exactly getting with respect to the formula, right? Now let's consider this, and in most of the book notation that you will also be seeing, right? In the books and all, you will be able to see like this. Let's say if you have a projection of line B of the vector A, right? It can also be specified like this: A dot B divided by B dot B dot product with B. Okay. You can also specify like this, but this exactly means one and the same. Okay. But again, the notation may be different, so it won't matter that much, right? But at the end of the day, you'll be able to understand it. Okay. So guys, now finally, I'm going to just write this entire formula, and this is what a projection of any vector to a line L is basically given by the specific formula itself, right? So let me just go ahead and write it once again for you. So projection of any vector X on L is nothing but it is X vector with the dot product of V divided by V vector with the dot product of V, and this entire will be a dot product with V. Okay. So this is what is the entire formula. Okay. And what does this basically specify? We will also discuss about this. Okay. Let me do one thing. Let me take this. Yeah. So now this is my final formula. Now this indicates what does it indicate? Let's say if I have a vector on a specific line, let's say this is the line, and if I have another vector which is denoted by this. If I want to probably do the projection on them, right, this projection of this vector x bar on L, this is x vector on L is denoted by this entire formula, and this is what is the projection we'll be able to get. The new point over here. What will be the new point? Let's say if this is 2, 3, after projecting, what should be the point over here? We need to find it out by using this formula. Okay. Now let me do quickly one thing. Let me just solve this by using a very simple formula, and then you will probably be able to understand. So let's go ahead and solve one of the problem statement. We will consider a vector. We'll consider one direction vector or line vector over here, right? I'll not say line vector, but just imagine a vector that is being converted into a line by multiplying with the value of c, and then we'll try to solve a problem. So let's go ahead. So guys, now here I will take a very simple example just to show you one way of how to calculate the projection. Let's consider our line. This line is nothing but it is a scalar multiple of a vector that is 1, 2. Let's consider this, or 2, 1. Okay. So this is what my line looks like how we specifically write C vector, right? So V is nothing but this. Okay. And here C belongs to your real number. Okay. Now if I have this specific vector, okay, and let's go ahead and denote this vector also if you want, and based on this, let's say I will go ahead and write this over here. Okay, so let's consider this, and let's consider our vector x bar is nothing but 2, 3, because we are going to project this specific vector on this scalar line. Okay, so here right now 2, 1 is nothing but, let's say this is 1, 2, 3, 4. This is 1, 2, 3, right? 2, 1 is nothing but this specific point, right? So if I do any dot product with respect to a scalar value, this is going to get extended like this, right? So right now let's consider this as 2, 1. Okay. I will also be talking about this 2, 3 point. So where does x vector fall? So there's 2 and this is 3. So x vector is over here, which is denoted by 2, 3. And this is the vector that we specifically have with respect to x. Now my main aim is basically to do the projection over here. Now I need to find what is this new point, and this new point is nothing but it is the projection of x vector on L. All right. Now in order to compute this, let's go ahead and use the formula. Now I think it should be very easy for you all, right? So projection of x vector to L is nothing but, first of all, I have x vector dot v vector. So what is x? X is nothing but, let's consider this entirely written like this. So 2, 3 dot product with vector v. Vector v is nothing but, what is the vector v over here? It is nothing but 2, 1. So I will do the dot product with this, and finally I will do another dot product with v, right? So what is v over here? V is nothing but this is v. Okay, 2, 1. We are doing a dot product with 2, 1 again, and this will be dot product with another vector 2, 1. Okay, so finally here you'll be able to see that. Let's go ahead and calculate it. So when we do this vector dot product with this, it is nothing but 2 multiplied by 2 is 4 plus 3, right? So here you have 7 divided by, so this is nothing but 2 plus 1, right? So sorry, 2 multiplied by 2 is 4, and then 1 multiplied by 1 is 1, right? So once we specifically do this, here you will be able to see the calculation, and here I'm actually going to get the value as 5, right? So 7 by 5 with dot product with 2, 1. So here if I do the further calculation, when I probably, it's just like multiplying with a scalar value, right? So here you'll be having a new vector. It is nothing but 14 by 5, and then here I have 7 by 5. So whatever value this is, 14 by 5 and 7 by 5, this is nothing but, if I go ahead and calculate it, it is 2.8, 1.4, right? So once this 2.8 and 1.4 will be this new coordinate. So this is nothing but 2.8 comma 1.4, right? Once we do the projection over here, this is the new value that we are going to get. And this is what is your projection of x bar on the vector L. Okay. So this is overall the entire projection that we have specifically discussed about with an example, and I hope you're able to understand this, right? So you take up any points in this, any kind of vectors, you should be able to calculate this. So I hope you like this particular video. This was it from my side. I'll see you all in the next video.